This says determine whether the quadratic function has a maximum or minimum value, then find that value. So first of all, we have to determine if it has a maximum or minimum value. What does it have? It has a maximum. How do you know? The negative. Right. So if I were to think about roughly what this is going to look like, it's going to go downward like that. So, what do we do first to get into vertex form? Subtract 4, right. Subtract 4. So if I subtract 4 on both sides, then I end up with y minus 4 equals negative x squared minus 4x. Okay, what's the next step? I have to do what? Complete the square, but I have to take out what first? The negative, thanks. Okay, take out the negative. And then I complete the square. So once I take out any GCS, like if I'm holding by a GCS, where I take out a negative, if there's a negative, then I can complete the square. So, let me do that. Y minus 4 plus blank equals negative x squared plus 4x plus blank. What goes in the blank? 4. 4 in this one. What in this one? Negative 4. Y minus 8 equals negative, what does that have to be? Yep. X plus 2 times squared. And then, what do I do? Add 8. Now I have it in vertex form. So y equals negative x plus 2 quantity squared plus 8. What's my vertex? Opposite sign, negative 2, 8. What's my max? Be prepared to do that on the test and show all the steps. If you have any questions. Okay. Last section. So, solving quadratic equations. How can you use the quadratic formula to solve quadratic equations? By completing the square for the quadratic equation, which you can do for bonus points, you can develop a formula that gives the solutions of any quadratic equation in standard form. This formula is called the quadratic formula. So you creative geniuses will think of a way to remember this, and you need to memorize this. Okay? You need to know it. You need to know it from here on out. And this is a formula almost everyone remembers forever because everyone drills it into them. Algebra 1 teachers, Algebra 2 teachers, calculus teachers, you're just going to know the quadratic formula. So if you can think of a creative way to remember it, that's great. The one thing about the quadratic formula is sometimes it becomes a bit of a crutch for people. So once people learn the quadratic formula, because it always gives the right answers, people will always try and use the quadratic formula. Stray away from that. Because we learn how to factor, we learn how to complete the square, not only to find solutions to quadratic equations, but for example, with completing the square, putting something in vertex form. I would say that if the problem is too difficult to work with, if you're dealing with decimal coefficients, for example, like 1.3x squared, or you're dealing with very large coefficients, like 227. Let's say you're dealing with 227x squared plus 50x plus, 23 equals 0, and you have to find the solutions to that, then use a quadratic formula. That's way too difficult to try and solve by completing the square or by factoring. So basically, when in doubt, the quadratic formula is there to help you find those answers. Does that make sense? Okay, so one of the important things that we need to remember about the quadratic formula is that just like when we solve by factoring, it has to be set equal to what? 0. Okay? So make sure your equations are set equal to 0. This inside part here is going to tell us a lot, whatever's inside the radical. Okay? Where do A, B, and C come from? So, these come from your standard form of your quadratic equation. Ax squared plus bx plus c. Okay? So, what I would do, at least starting out, while you're learning the quadratic formula, is list what your A, B, and C are every single time until you get used to it, because you don't want to mess up the signs first of all. And they're just the coefficients in front of the variable. Coefficient meaning just a number, right? And C is obviously just a number. We're going to talk about how this tells us how many solutions we're going to have, whether or not we're going to have any real solutions, one solution, or two solutions. Notice that A cannot be 0. Why can A not be 0? Do you think? What on this formula indicates to me that A being 0 would be problematic? Yes?
0 is 0, divide by 2.
Well, close, right? If it was 0, you'd be dividing by 0. Well, we don't want to divide by 0, right? Because 2 times 0 is 0. If A was 0, right? B squared minus 4AC has to be greater than or equal to 0. Well, what happens if this is negative? Can we take the square root of a negative number and be in the real number system? No. That's imaginary, right? So this, in order to get real solutions, this has to be greater than or equal to 0. So anytime we get less than 0, we automatically know that our solutions are imaginary. Okay? This is called the discriminant, and we'll talk about that. Okay, here we go. So, whether it's Pop Goes the Weasel or a rap or whatever you come up with to remember this, or you just plain memorize it, you need to know the quadratic formula. So it says, solve 2x squared minus 5x plus 3 equals 0 using the quadratic formula. Okay. You could factor this if you wanted to, if I said use any method, which we are going to look at on Monday. We're going to look at just all three methods and deciding which one to use, because that can be kind of difficult. But let's use the quadratic formula on something relatively easy first. So I want to list my A, B, and C. First I have to verify that it's set equal to 0, which it is. Now, what is my A? Sorry. My B? -5, and my C? 30. Okay. So, quadratic formula, opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Okay? Memorize that and know it for the test. Okay. So I'm going to just replace everything with those terms. So opposite of B would be what? 5. 5 plus or minus the square root of B squared. So what's B squared? 25 minus 4 times A. What's A? 2. Times C. What's C? 3. Now one thing you want to know is if these are negative, then you need to make sure you watch the sign here. Because if one of these is negative, then the whole thing becomes positive, right? You're adding before it's subtracting, so make sure you keep that in mind. All over 2A, so 2 times 2. Alright, here's what we're going to do. Plus or minus, because we should have two answers, right? If it's 1 or 2. So, unless it's no real solutions. So 5 plus or minus the square root of 25. What's 4 times 2 times 3? Huh? 24. 25 minus minus 24 all over 4. So let me just number these so we don't get confused. Step 1, step 2, step 3. And lastly, step 4, we're just going to simplify everything, put everything together, combine all our like terms, etc. And we end up with step 4 finally, which is 5 plus or minus the square root of 1 over 4. This plus or minus, again, means that I'm going to have two answers. One of my answers is going to be 5 plus 1 over 4. The other one's going to be 5 minus 1 over 4. So my x values are x equals 6 over 4, which what does that reduce to? 6 over 4 reduces to 3 over 2. And then 4 over 4 reduces to 1. Okay. Do you have questions on that? For those of you that like just a method to your madness, this is it. Okay, this will not fail you. If you can memorize it, you're golden. Okay. And when Ramsey performs tropical cerebral serum, we'll all remember it. Okay. Let's take a look at number 2. I'm going to list my A, B, and C values. What's A? Number 2. 1 half. What's B? 1. What's C? Negative 10. Right? When you write the formula, opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Okay, opposite of B would be what? Negative 1. Negative 1 plus or minus the square root of B squared. What's B squared? 1 minus 4 times A. What's A? What's C? Negative 10. Okay. So since I have a negative and a negative, what am I going to end up with here? You're adding something, right? Does that make sense? Okay. All over 2A. 2 times what? 1 half. So, now, we're going to take this and we're just going to simplify everything. Negative 1 plus or minus the square root of 1 minus, well, let's do plus, right? So we have a minus and a minus. So 4 times 1 half is 2, and 2 times 10 is 1. Does everybody understand why I just made that a plus? Okay. All over what? All over 1. Okay. So, you have negative 1 plus the square root of 21 over 1 and negative 1 minus the square root of 21 all over 1. If I didn't ask you to give me decimal approximations, what you would need to do is simplify your radical if you could. Okay? So you'll run into a lot of worksheets and problems in the future where you'll do all this and you'll end up with something and then not sort of approximate the answer or give decimal approximations. So you'd have to just give these as your answers and check to see if you can simplify these radicals. And send it to your class. Yes?
Would you get it wrong if you didn't simplify them?
If the question did not tell you to approximate, as this one did, if the question did not tell you to approximate, you would get it wrong. Okay? Because you want an exact answer. That's a good question. This is an exact answer versus an approximation.
So it asked for an approximation and
which these say round to the nearest tenth if necessary. That's why those final answers were decimal approximations. Does that make sense? Okay. So I'm going to give you an example. Let's say we've done our quadratic formula to try and find the solutions of something. We end up with, say, -1 plus or minus 1/2. Then let's look at another situation. We have -1 plus or minus 0/2. And then let's look at a third situation. We have -1 plus or minus the square root of -1/2. So all we really need to focus on is the inside of the radical. What does that tell me about the solutions? They're not real, right? They're not real solutions. Meaning that this is what the parabola looks like. Does that make sense? So you can determine right away, you don't have to look at the quadratic formula in its entirety, just the b squared minus 4ac part to know the number of solutions it's going to have. Here, if it's just 1, if I just have a positive value, I'm going to have two solutions. -1 plus 1 divided by 2 and -1 minus 1 divided by 2. Those are two distinct solutions, right? Therefore, I'll have two x-intercepts. Two solutions, two x-intercepts. Those solutions are where it crosses the x-axis, right? Now, if I have 0, isn't -1 plus 0 and -1 minus 0 the exact same number? Yes? That's why you would have only one solution. So, the moral of the story is, to determine the number of solutions that you have, you are looking at the discriminant. What is the discriminant? The discriminant is the b squared minus 4ac part of your quadratic formula. If it's negative, then you have non-real solutions. If b squared minus 4ac is positive, then you have two distinct solutions. If b squared minus 4ac is 0, then you have one solution. Questions? So maybe I should write that here. No reals, two solutions, and one solution. And this says determine the number of real solutions for each equation. So I just have to look at b squared minus 4ac. I don't have to look at the radical, just b squared minus 4ac, right? So, what is b, what is a, and what is c? What's b? What's a? 1, what's c? 2. So, b squared would be what? Minus 4 times a times c. What does this end up being? 64. Negative and negative make a. So I have b squared minus 4ac, 64 plus 12. So how many solutions do I have? 2. I already know. I have a solution. 2 real. Two real solutions, therefore meaning how many x-intercepts? 2. 2 real solutions. 2x. Understand that? Okay. Okay. What do I have to do first? Yes, z equals 0 first. 9x squared plus, minus 6x. Put it in standard form, of course. Minus 6x plus 1 equals 0. A is 9, B is, C is 1. B squared minus 4AC. So what's negative 6 squared? 36. Minus 4 times A is 9 times C, which is 1. What do I end up with? 46 minus 36. Which is 0, which means how many solutions? 1 real, which means how many x intercepts? 1 x intercept. The discriminant is extremely useful, especially when you're looking at more complicated parabolic equations and graphs. So you want to know, where does it cross the x-axis, or how many times does it cross the x-axis, how many solutions do it? Extremely important. Okay. Alright, try those.